Hurricane Milton recently made landfall on the coast of Florida, leaving a trail of destruction in its wake. The media has been saturated with images of flooded streets, uprooted trees and damaged homes, reminding us of the raw power that hurricanes possess. These storms, a formidable display of nature's fury, serve as a stark reminder of our planet's capricious weather patterns and their potential to wreak havoc. Hurricanes, with their swirling masses of clouds, torrential rainfall and destructive winds, are a force to be reckoned with. Hurricanes are born over the warm waters of the tropics, drawing their energy from the immense heat of the ocean's surface, which acts as a vast reservoir of thermal energy. As the sun beats down on the ocean, it warms the surface layers, causing water to evaporate and rise into the atmosphere, creating a continuous cycle of energy transfer. This warm, moist air is the essential fuel that drives a hurricane's powerful engine, setting the stage for a dramatic weather event. As the warm air rises, it cools and condenses, forming towering thunderstorms that can reach heights of several miles. These thunderstorms, clustered together, begin to rotate around a central point of low pressure, creating a spiraling system. This rotation is a result of the Coriolis effect, a fascinating phenomenon caused by the Earth's rotation, which influences the direction of the storm's spin. The rotating mass of thunderstorms continues to draw in warm, moist air from the ocean surface, further fueling its growth and intensifying the storm. As the storm intensifies, winds pick up speed, spiraling inwards towards the central point of low pressure, known as the eye, where the pressure is at its lowest. The eye of the hurricane is a zone of relative calm, surrounded by the most intense winds and rainfall, creating a stark and dramatic contrast. This eerie calm at the heart of the storm is a stark contrast to the raging winds and torrential downpours that characterize the hurricane's outer bands, where the storm's true power is unleashed. Hurricanes, typhoons and cyclones are all essentially the same weather phenomenon, powerful rotating storms with torrential rainfall and destructive winds, capable of causing widespread devastation. The difference lies in their geographical location and the names assigned to them by different regions of the world, reflecting cultural and linguistic variations. In the North Atlantic, Central North Pacific, and Eastern North Pacific, these storms are called hurricanes, derived from the name of the Caribbean god of evil, Hurricane, symbolizing their feared nature. In the Northwest Pacific, they are known as typhoons, possibly originating from the Chinese word typhoon, meaning big wind, indicative of their immense power. In the South Pacific and Indian Ocean, they are referred to as cyclones, derived from the Greek word kyklon, meaning moving in a circle, describing their spiraling motion. Tornadoes, while often associated with severe weather, are distinct from hurricanes and cyclones. They are smaller, more localized rotating columns of air that form over land, often in association with thunderstorms, and can appear suddenly. Tornadoes, though short-lived, can be incredibly destructive, with wind speeds reaching up to 300 miles per hour, leaving a trail of destruction in their wake. Hurricanes leave behind a trail of devastation, not only to human infrastructure, but also to the natural environment. The aftermath is often a stark reminder of nature's immense power and the vulnerability of our built and natural environments. The powerful winds, torrential rainfall and storm surges associated with hurricanes can have a profound impact on coastal ecosystems, forests and freshwater systems. These natural disasters can disrupt the delicate balance of these ecosystems, causing long-term damage that can take years to recover from. Coastal areas bear the brunt of a hurricane's fury, with storm surges inundating low-lying areas, eroding beaches and damaging coral reefs. The loss of these natural barriers can leave coastlines more vulnerable to future storms and rising sea levels. The influx of salt water can be devastating to coastal vegetation, while the physical force of the waves can uproot trees, destroy seagrass beds and reshape coastlines. This reshaping can alter habitats for marine and terrestrial species, leading to further ecological consequences. Inland, Heavy rainfall can lead to widespread flooding, overflowing rivers and streams and saturating soils. This not only affects human settlements, but also disrupts the natural flow of water, impacting wildlife and plant life. This can trigger landslides, erode soil, and wash away nutrients, impacting both agricultural land and natural ecosystems. The loss of fertile soil can have long-term effects on food production and biodiversity. Forests can be severely damaged by high winds, with trees uprooted or snapped, leaving behind a swathe of debris that can alter habitats and increase the risk of wildfires. The fallen trees and debris can also hinder forest regeneration and recovery, making the landscape more susceptible to future environmental stresses.